and welcome to Math 6 BCPS-TV style. My name is Mrs. Potter, and I'm your host for today's episode. Before we get started doing math, I want to tell you a little bit about me. I love math jokes. They're one of my favorite things to share with other people. So today, I'm going to share with you one of my all-time favorite math jokes, but I'm going to tell you the answer at the end of the episode, so you'll have to tune in to the end to hear the answer. So here's the joke. What did the 0 say to the 8? Tune into the end to find out the answer. Let's get started today with a Think About It task. Today's Think About It task asks you to think about and describe a situation where you are dependent on someone, and to also think of a synonym for the word depend. Take a few seconds to think about this Think About task. And now, my family is here to tell you about their situations. As you listen, pay close attention to the situation and the synonym they came up with for the word depend. Hi, Lily.
Hi.
Can you describe a situation where you were dependent on someone?
Well, right now I'm dependent on my parents to keep me safe and healthy from the pandemic happening outside.
Okay. And can you think of a synonym for the word depend?
To need and trust and needing someone to help you through stuff.
Nice. Thank you.
You're welcome.
Hi, Spencer.
Hello.
Can you describe to me a situation where you were dependent on someone?
Yeah, so a recent situation where I'm dependent on someone would be now actually. During this no school period, I'm semi-dependent on my teachers to provide work for me and to provide instructions on how to prepare for the AP tests and stuff like that. So I'm dependent on my teachers in a way right now.
And can you think of a synonym for the word depend?
Rely on.
Rely on. Nice.
Yeah.
Thanks, Spencer.
You're welcome.
Hi, Victoria.
Hi.
How are you?
Good. How are you?
Good. Can you describe a situation where you were dependent on someone?
I feel like I'm pretty dependent on my mom, who helps me pay for college and really helps me with my financial situations.
Okay. And can you think of a synonym for the word depend?
In need of.
In need of. Nice. Thank you very much.
You're welcome.
The material covered in this first mini lesson today is the same as the material in your print packet for Math 6 during the week of April 27th. On the screen is our first learning objective for today. Today, we will identify independent and dependent variables from both tables and graphs. And now we're going to learn about it. In this section, we're going to be learning about independent and dependent variables. In the Think About It task, we thought about situations where we depended on someone else. So keep that in mind as you learn about independent and dependent variables. Often in mathematics, we look at real-world situations, and those real-world situations can be presented to us through words, with a table, or with a graph. And those real-world situations have two variable quantities where one quantity depends on the other quantity. So let's talk about our definitions for independent and dependent variables. And I want you, as I'm doing this, to think back to the situations in the Think About It task where you heard how my family members depend on someone else. The quantity that depends on the other quantity is called the dependent variable, and the quantity that it depends on is called the independent variable. So in this situation with Victoria depending on her mom would be the independent variable, and Victoria would be the dependent variable. This can be a little bit confusing when you're just thinking about those definitions without a real-world situation, so let me give you another way to think about it. The independent variable often determines the dependent variable. So Victoria's mom provided her support, which helps determine what Victoria is able to do with school. The dependent variable depends on the independent variable. So Victoria depends on her mom to help support her with her college costs. So let's learn about it. In this first example, we're going to be looking at a table to help us find independent and dependent variables. A freight train moves at a constant speed. The distance y in miles that the train has traveled after x hours is shown in the table. So I can see that my two variable quantities are time and distance. And I can also see that as the time increases, the distance that the train has traveled also increases. So my first question is, What are the two quantities in this situation? The two quantities in this situation are time and distance. The next question that I'm asked to answer is which of these quantities depends on the other? So I'm going to actually write two sentences to help me with that. The first sentence that I'm going to write is that time determines distance. And then I'm going to also notice that distance depends on time. So I've answered the question, which of these quantities depends on the other? Distance depends on time. So my last steps are to identify the independent and dependent variable. In this particular situation, the independent variable is time, and the dependent variable is distance. I'm also going to give you a hint about what to look for in a table to maybe make this a little bit easier. You'll notice that my time was also identified with a variable of x, and my distance was identified with a variable of y. And if you're comparing two quantities and they are labeled as x and y, often the independent variable is x and the dependent variable is y. This isn't always true, so it's really important that you always go back and write these two sentences to help you determine which quantity depends on the other. In example number 2, we're going to be looking at a graph to help us identify the independent and dependent quantities. So let's take a minute and read the problem scenario and make some connections to the graph. An art teacher has 20 pounds of clay, but wants to buy more clay for her class. The amount of clay purchased by the teacher and the amount of clay available for the class are shown on the graph. So along the x-axis, I'm representing those values as the clay bought by the teacher in pounds. And on the y-axis, I'm representing that with the clay that's available for the classes. So it looks like as I increase the amount of clay bought by the teacher, the clay available for the classes is also increasing. And now I'm going to answer the same 4 questions as I did in example 1. What are the two quantities in this situation? Which of these quantities depends on the other? The independent variable and the dependent variable. So the two quantities in this situation, I can get that from either going back and looking at the word problem, or I can look at the graph that is represented and the two quantities on the x-axis and the y-axis. So the two quantities in this situation are the clay bought by the teacher and the clay available for the classes. So the next question asks me to identify which quantity depends on the other. So I'm going to use my same 2 sentences as I did before. So the first thing that I'll write is that the clay bought by the teacher determines the clay that's available for her classes. And I'll also write that the clay available for the class depends on the clay that's bought by the teacher. And this second sentence right here is the sentence that I'll use to help us identify the independent variable and the dependent variable. The independent variable is the clay bought by the teacher. Also notice that this is the quantity on the x-axis. And the dependent variable is the clay available for classes. And this is the quantity that's represented on the y-axis. So now let's check your understanding. On the screen is a real-world problem situation, and I'll put up 2 multiple choice questions for you to identify the independent and the dependent variable. Gina is charged 15 cents for each text message that she sends. What is the independent variable? The number of texts sent, the charge per text, or the total amount charged for texting? The independent variable is the number of texts sent. What is the dependent variable? The number of texts sent, the charge per text, or the total amount charged for texting? The dependent variable is the total amount charged for texting. So let's take a look. The total amount that's charged for texting depends on the number of texts that Gina sends. Today, our learning objective was to identify independent and dependent variables from tables and graphs. We saw one example with a table and another example with a graph. In your print packet, there are lots of different problems and activities to practice identifying independent and dependent variables. One of the activities is a matching task. Those are my favorite kind of activity. And now it's your turn to try it and show what you know. A good strategy is to look back at the examples to help you if you get stuck. Before we move into our second mini lesson, let's switch gears and complete a think about it task. I want you to imagine a hot dog stand that charges $3 per hot dog. What questions could you ask about this situation? I asked my family to come up with some questions, but when they share their questions, I'm also going to ask them for their answer. As you listen, try to follow along with their explanations. Hi, Finley.
Hello.
How are you today?
Good. How are you?
I'm good. So we have this hot dog stand and it charges $3 per hot dog. What were the questions that you came up with?
I wondered if I bought 15 hot dogs, how much would it cost? So if I have 15 hot dogs and it's $3 per hot dog, then it would be 15 times 3, which is equal to $45.
So you said that you were going to buy 15 hot dogs. Were you going to eat them all by yourself?
I was going to share them with Victoria.
Oh, okay. That's really nice of you. Okay. What was your second question?
My second question was if I won the lottery and got $1 million, how many hot dogs could I buy?
Okay. So how many hot dogs could you buy?
Well, if I have $1 million and it's $3 per hot dog, I could do 1 million divided by 3 to figure out how many hot dogs I could buy. That simplifies to 333,333.3 repeating. However, you can't buy a third of a hot dog, so I'll just be able to buy 333,333 hot dogs. Definitely the best way to spend your money.
Nice. Would you have any money left over?
I would not. Wait, yes, I would. I would have $1 left.
$1 left?
Yeah.
And maybe you could buy some
I could buy
condiments.
some, yeah, ketchup for all my hot dogs.
Nice. Thanks, Ben.
Yep.
Howdy, Tim.
Howdy, Lar.
How's it going?
It's going great.
So what is your question about the hot dog stand that charges $3 per hot dog?
Well, I wanted to know what my total bill would be if I wanted to buy each person in my family a hot dog. Then I remembered that there's a 6% sales tax in Maryland. So my question is, if I buy a hot dog for each person in my family, 6 people, and the tax in Maryland is 6%, what will my total bill be?
So how did you calculate that total bill?
So there's 2 ways to do it. The first way would be to calculate the total price of a hot dog. So you can take $3 and multiply that by 1.06 to get $3.18 per hot dog. And then you can multiply that by 6. And that will give you $19.08.
Okay.
But I didn't do it that way. I did it the second way. And I think this is a little bit easier. So I can take $3 per hot dog and multiply that by 6, which would give me $18. And then I have to add the sales tax onto that. And so $18 times 1.06 is $19.08.
So I have one last question for you. In both ways, I noticed that there's a multiply by 6, and there's also a multiply by 1 600ths. I understand that the 600ths comes from the 6%, but where does the 1 come from?
Yeah, so that's just a shortcut. So you could have done $3 times 6%, and you would have got 18 cents, and then you'd have to add that to $3 to get a total of $3.18. But I combined using a factor process the $1, the 1, and the 6%. So that's where you get the 1.06 from.
1 600ths.
Yeah.
Thank you. The second learning objective in this video is the same as the material in your print packet for Math 6 during the week of April 27th. This is lesson number 2. Today, we will use verbal descriptions, tables, equations, and graphs to represent algebraic relationships. In this Learn About It section, we're going to be talking about the many representations of situations that can happen in mathematics. One way that you might see a situation represented is in words, and this would be a verbal description of the situation. You can take that verbal description and identify the independent variable and the dependent variable by using the information that I presented in the previous lesson. Another way that you might see a real-world situation represented is in a table, like the problem with the train in the previous lesson. Again, we want to make sure that our table is organized with an independent variable and a dependent variable. Another way that you might see the situation represented is with an equation. So we'll take the verbal and translate that into an algebraic equation. And the last way that you might see, let me move my face. The last way that you might see a real-world situation represented is with a graph, where the independent variable is along the x-axis and the dependent variable is along the y-axis. So let's take a look at an example to see how we would fill out a multiple representation table. In this Learn About It example, we're going to review a real-world situation that's written in words and create a table, an equation, and a graph to represent that situation. So let's get started. Kevin earns $5.50 for each hour he babysits on the weekend. So when I think about that scenario, I know that the amount of money that Kevin earns, the total amount that he earns, depends on the number of hours that he works. So my dependent variable is total earnings, and the independent variable is hours worked. And we know that Kevin is working by babysitting. I'm going to also label each of these independent and dependent quantities with a variable. I'm going to represent hours worked with H and total earnings with a capital E. So the next thing that I'm going to do is I'm going to create a table of values that represents some specific instances about the number of hours that Kevin works. So I'm going to begin by labeling the first row in my table with my independent and dependent variables. So my hours worked, I'm representing that with an H, and my total earnings, I'm representing that with an E. So I'm going to think about a couple situations that Kevin might be babysitting. He might be babysitting for 1 hour, he might babysit for 3 hours, or he might babysit for 4 hours. So if Kevin babysits for 1 hour, his total earnings will be $5.50. I got that by multiplying 1 hour times $5.50 per hour. If Kevin works or babysits for 3 hours, his total earnings will be $16.50. I got that by multiplying 3 hours times $5.50 per hour. And last but not least, if Kevin works for 4 hours, his total earnings will be $22. And I got that by multiplying 4 hours times $5.50. The next representation that I'm going to use to model this real-world scenario is an equation. I'm going to begin by writing it in words, and then I'm going to identify the independent and dependent variables, and then I'm going to write it as an algebraic equation. So let's make sure I have my pen on. So Kevin's total earnings are calculated by multiplying his earnings per hour times the number of hours. So we can see that up in the table that I multiplied the earnings per hour, $5.50, times the number of hours that Kevin worked to get the total earnings. So now let's represent this with an equation. The variable that I used to represent total earnings was E, and Kevin's earnings per hour were $5.50. And I multiply $5.50 by the number of hours, or H, to get my total earnings. So the equation is E equals $5.50 times H. The last representation that I'm going to use to represent this word problem about Kevin is a graph. And I'm going to be plotting the points that I created in my table to help me see visually what's happening with this. So the last thing that I'm going to do is plot the points from my table onto my graph so that I can get an accurate representation of this relationship. So the first entry in my table says that if Kevin works for 1 hour, he earns $5.50. So I'm going to start at the origin, move to the right one along the hours axis, and move up to $5.50. So there's my first point. If Kevin works 3 hours, he earns $16.50. So I'm going to start at the origin, go to the right 3, and go up along the earnings axis to $16.50. And for the last entry, Kevin earns $22 for 4 hours. So I'm going to start at the origin, move to the right 4, and go up to 22. And I have my last point. The last thing I'll do, because it's a possibility for me to work partial hours, is connect all of my points with a line to show all of the relationships between the number of hours worked and total earnings. Now I have a completed multiple representation chart showing a word problem with words, a table, an equation, and a graph. Today in our lesson, we used verbal descriptions, tables, equations, and graphs to represent algebraic relationships. We also made a connection back to our work with independent and dependent variables in the previous lesson. In your print packet, there are 2 more situations where you are asked to create a table, an equation, and a graph based on a verbal description. Make sure you identify the independent and dependent variables as you work. And now it's your turn to try some problems and show what you know. Look back at the example in the print packet to help you. It is an excellent model to refer to if you need some help getting started. So I didn't forget. I had a math joke at the beginning, and it was, what did the 0 say to the 8? Favorite math joke of all time. Nice spelling. Thank you for tuning in to BCPS-TV to learn math with me today. You should be ready to complete the Try It and the Show What You Know problems in your print packet. Applying what you learned is very important to solidify your learning. See you next time.